How do you know what you know and who told you so? Part 6. What God wants you to know. Let's look again at fine-tuning, but this time not at constants. Let's look at some of the peculiar circumstances of Earth, the planet on which we find ourselves. One of these peculiarities is how relatively large and yet close our moon is. It is so large that as it travels around the Earth, it causes large fluctuations in tides, resulting in mixing the waters and changing the weather. It also results in breaking and moving large plates on the surface, recycling our soil and air, and keeping its iron core molten, producing a magnetic field. That in turn prevents the solar wind from stripping away our atmosphere. If any of these were missing, we would not survive. But there is an even more interesting point. It has to do with the Earth and Moon and their relation to the Sun. You see, it just so happens that the diameter of the Moon is 1/400th of the diameter of the Sun. And the distance from the Earth to the Moon's diameter is also 1/400th the distance from the Earth to the Sun's diameter. That means that as the Moon rotates around the Earth, it will at predictable times perfectly block out the Sun from certain places on Earth. Now please consider that there are over 160 moons in our solar system, all different sizes and different distances from the planets. And not a single other one creates this condition for its planet, which has allowed us on our planet to see things not otherwise visible, to see the cause of the solar wind, to discover the composition of stars, even to verify Einstein's proposition that gravity bends light. If the diameters and distances were just a few percent more or less, we would see nothing. So, not only did God create the material universe and laws that govern it, but this suggests He intentionally set up circumstances so that we could learn about them. But we have statistical evidence not only that God wants us to learn about the universe, He also seems to want us to learn how to use the universe. Technology is there to be discovered. For this point, we begin with ancient Rome. The Romans didn't invent the arch, but they certainly capitalized upon it. They also learned that by mixing a little powdered limestone, clay, and volcanic sand with water, they could cement the arch together. This resulted in structures far taller, stronger, and longer lasting, so long that many of them still stand today. Perhaps that's why it took so long before anyone discovered that by altering the recipe slightly to include a little gypsum, one could build with the mixture itself, which we call cement. This new invention was great for compression. You could stack it really high. But if you tried to stretch it any, like in the tension of a beam, if they'd only known about iron. Well, okay, so they did know about iron. The Romans used it for surgical tools, horseshoes, you name it. But it never occurred to them to drop it into wet cement, or, in their case, mortar. Turns out that iron was the missing ingredient. An iron rod in the bottom of a beam absorbs the tension and carries the weight to the end support. But there's another consideration. What if changes in temperature affect the two elements differently? This does happen. Things expand and contract at different rates. It could be a problem. There is a way to measure and compare this potential change in dimensions. It's called the coefficient of linear expansion, abbreviated as alpha. It is in fact different for different building materials, and it in fact can ruin construction. It turns out that for the basic iron, the variation in length is right at 0.000006 inches per inch per degree Fahrenheit. Not much, but it doesn't take much to cause a problem. It turns out that for basic cement, the figure is identical to the 6th decimal place. Well, never mind that. With the discovery of steel and its mass production, we have learned to make iron stronger, but the introduction of carbon in the mixture changed alpha. And cement, we greatly improved it. Why, now it will even harden underwater. And its alpha has also changed to be the same as steel to the 7th decimal place. This has freed us to make huge advances in architecture and engineering all over the world. Now, lest we consider this to be some kind of coincidence, or that everything has similar alphas, let's look at some other alphas on the same scale. There are no other common materials, construction or otherwise, that come close to this alpha. Steel and Portland cement are totally unique. The best explanation is that God not only wants us to learn about our universe, but He wants us to learn about technology. With this conclusion, it is not difficult to imagine that just perhaps He wants us to learn about Him.